In previous session, we have seen how to find the circumcenter, incenter, excenter, orthocenter, and centroid of a triangle when the vertices are known. In this session, we'll see how to find these points when the equations of the sides of a triangle are given. Let us consider three sides here. These are the three sides. So to find the points using these three sides, initially we have to find the vertices. For that, we will find the point of intersection of these lines. We'll take two sides at a time and then we'll find the point of intersection. Now let us consider the first two equations, that is 1 and 2. The first equation is x plus y plus 10 equal to 0, and the second one is x minus y minus 2 equal to 0. Now add to these two equations, we'll have 2x plus 8 equal to 0, plus y and minus y will get cancelled out. X is equal to minus 4. Substitute this minus 4 in any one of the equations. Let us take this equal to 0. Now in place of x, write minus 4 is equal to 0. Take y to the other side. It gives y is equal to minus 6. So the point of intersection of first and second line is minus 4 comma minus 6. Write it down here. Now we have to find the intersection point for second and third equations. Second one is x minus y minus 2 equal to 0. Whereas the third equation is 2x plus y minus 7 equal to 0. Again add these two equations. X plus 2x is 3x. Minus y plus y will get cancelled out. Minus 2 minus 7 is minus 9 equal to 0. From this x is equal to 3. Now substitute value of 3 in the first equation here. That gives 3 minus y minus 2 equal to 0. Take y to the other side. Y is equal to 1. So the point of intersection of second and third equations is 3 comma 1. That gives the vertex B. Now we'll do the point of intersection for third and first equations here. We'll consider the third equation, that is 2x plus y minus 7 equal to 0, and the first equation is x plus y plus 10 equal to 0. Subtract these two equations. We'll change the signs here. Now plus y minus y will get cancelled out. 2x minus x is x. Minus 7 minus 10, that gives minus 17 equal to 0. From this x is equal to 17. Substitute this 17 in the equation. That gives 17 plus y plus 10 equal to 0. From this y is equal to minus 27. So the point of intersection of these two equations is 17 comma minus 27. Now we know all the three vertices of a triangle. We'll use the same method that we have discussed in the previous video to solve for the points. Let us look into that again, but before that we will just try to see how the triangle here will look like. It's not required to draw the triangle, but this example we are going to use it to prove few of the cue points we have observed in the previous video. Now see, the triangle will look like this in the coordinate plane. The vertices and lines are also mentioned here. Just remember how this triangle is looking like. Now we'll start with deriving the points. The first thing is centroid. The centroid equation is pretty much easy. We just have to do x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. Let us do that here. Here minus 4 plus 3 plus 17 upon 3, comma, minus 6 plus 1 minus 27 upon 3. On simplifying this, it is 16 upon 3, comma, minus 32 upon 3. This is a value for the centroid. We'll see the value here. Centroid is represented using z. Z is 16 upon 3, comma, minus 32 upon 3. Next point is orthocenter. To find the orthocenter, we have to find the equations of the medians. When we take the triangle like this, for A, opposite side would be this third equation. We have to find the equation of a line passing through this point and perpendicular to the equation 3. Slope of this line is m is equal to minus 2. And now slope of a line that is perpendicular to this line would be We know this m1 into m2 is equal to minus 1, then both the lines are perpendicular to each other. We know one of the slopes, so obviously the second slope would be minus 1 upon minus 2, which is nothing but 1 upon 2. Now we know the point and the slope. We can find the equation. For that we have to use y minus y1 is equal to m of x minus x1. Y minus, here y1 is minus 6. So y plus 6 is equal to 1 upon 2. X minus x1 will have minus of minus, so plus 4. Simplify this, 2y plus 12 is equal to x plus 4. Now x minus 2y minus 8 equal to 0 is the equation of one of the medians here. Now we'll use the B point, the B vertex, and the opposite side for this is this first side equation. The slope of this is minus 1. From m1 into m2 is equal to minus 1. The slope of the line perpendicular to the above line is nothing but m is equal to minus 1 upon m, that is minus 1 upon minus 1 is 1. So the slope is 1. The equation is y minus 1 1. That is y minus 1 is equal to m, means 1 of x minus x1, that is 3 here. Now if we simplify this, take y to the other side, that gives x minus y minus 2 is equal to 0. This is the equation of the second median we have here. To find the orthocenter, now find the point of intersection for these two lines. When we find the point of intersection for these two lines, we'll just write x minus 1 minus 2 is equal to 0 and try to subtract these two equations. Change the signs here. Then plus x and minus x will get cancelled out. Minus y plus 2y is y. Minus 2 plus 8 is plus 6 is equal to 0. From this we'll have y is equal to minus 6. Now substitute this y is equal to minus 6 in the first thing. We'll have x minus of minus 6 minus 2 is equal to 0. Then minus of minus is plus 6. 6 minus 2 is 4. So x is equal to x plus 4 equal to 0, which means x is equal to minus 4. We have got this coordinates of orthocenter to be minus 4 comma minus 6. Now observe these coordinates. If we observe this coordinate, orthocenter is usually represented by letter H. This is similar to one of the vertices A here. From the previous video, if we can recollect, for a right angle triangle, orthocenter would be the vertex of the right angle triangle. Also, we have to see how this triangle will look in the previous slide. It is something like this. So here we can clearly see it's a right angle at A. So this is the vertex that has got the right angle, minus 4 minus 6. So this is the orthocenter. When the sides of a triangle are given, to find orthocenter, instead of doing all the steps, first what we can do is find the slopes of the equations. For the first one it is minus 1, for the second equation it is 1, and for the third one it is minus 2. After finding the equation, see if any of these slopes are with the relation of first slope into second slope is equal to minus 1. This is the condition for the perpendicular lines. m1 into m2 is equal to minus 1. That's the condition. When we have that relation, we can directly write the point of intersection of those two lines to be the orthocenter. In this case, we have m1 is minus 1 and m2 is 1. When we multiply these two, it gives minus 1, which means these two lines are perpendicular to each other. That forms a right angle triangle, and that particular right angle is the orthocenter. So point of intersection of these two lines gives the orthocenter. Now we look into the circumcenter. For circumcenter, we know the relation that OA square is equal to OB square is equal to OC square, where O represents the circumcenter, which will assume to be H comma K. So we'll do all this now and try to find the circumcenter. Now here OA, OB and OC represent the distance between the circumcenter and the corresponding vertices. We'll start substituting the values here. This gives h minus of minus, that is plus 4 whole square, plus k minus of minus is plus 6 whole square is equal to h minus 3 whole square. plus k minus 1 whole square is equal to h minus 17 whole square plus k minus of minus is plus 27 whole square. Now we'll simplify this. This is h square plus 8h plus 16 plus k square plus 12k plus 36 is equal to h square minus 6h plus 9 plus k square minus 2k plus 1 is equal to h square minus 34h plus 289, that is 70 square, plus k square plus 54k plus 729, which is the 27 square. Now h square and k square will get cancelled out in all these three. We'll try to simplify these two first and then these two. We'll take all these values to the right. 8h minus 6h. So when minus goes to the other side, it's plus. 8 plus 6 is 14h. 12k minus 2k goes to the other side, plus 2k, that is 14k. 16 plus 36 is 52. Here 9 plus 1 is 10. To the other side, it's minus 10. So 52 minus 10 is 42 equal to 0. This is the equation. Let it be A. Now for these two simplification, we'll take this minus 34h to the other side. Minus 6h plus 34, that is 28h. Now we have 54k to the other side. It is minus 54 minus 2k, that is minus 56k. 289 plus 729. If we add these two things, it is 1018. When we take to the other side, it is minus 1018 plus 10, that gives minus 1008 is equal to 0. Let it be B. Now we are going to solve these two equations to find circumcenter, which is given by h and k. For that, we'll multiply A with 4. That gives 56h plus 56k. 42 into 4 is 168 equal to 0. Add these two things. 28 plus 56 is 84h. These two will get cancelled out. Then her minus 840 is equal to 0. We'll have h is equal to 840 divided by 84, which is nothing but 10. Now we have h. Substitute the value of h in this A. So 14 into h is 140 plus 14k plus 42 is equal to 0. 140 plus 42 is 182 plus 14k is equal to 0. K is equal to minus 182 upon 14, and this gives us one time 14 and then 3. Minus 13 is the answer here. So h comma k is nothing but 10 comma minus 13. So this is the value of the circumcenter we have. Now we know the circumcenter to be 10 comma minus 13. But from the previous observation, we know this to be a right angle triangle. For a right angle triangle, circumcenter is the midpoint of hypotenuse. Here the hypotenuse is BC, and we have the values here. To find the midpoint, it is x1 plus x2 upon 2 comma y1 plus y2 upon 2. When we do that for the BC vertices, 3 plus 17 upon 2 comma 1 minus 27 upon 2. This is nothing but 20 upon 2 comma minus 26 upon 2, that is 10 comma minus 13 is the circumcenter. So when we know the given lines represent a right angle triangle, we can directly follow this to find the midpoint of hypotenuse. We are done with calculating all the 3 points, that is centroid, orthocenter and circumcenter. These we will try to prove the second key point we have seen in the previous video, that is orthocenter, centroid and circumcenter are always collinear, and this centroid divides the line joining orthocenter and circumcenter in the ratio of 2:1. Both these points we'll look into. When we say the points to be collinear, we just have to find the area, and if area is equal to 0, it means they are collinear. Use and find the area of triangle. In place of x1, we have minus 4. Y2 is minus 13, minus y3, that is minus of minus is plus 32 upon 3, plus x2 is 10, y3 is minus 32 upon 3, minus y1, minus of minus is plus 6. Now we have x3 16 upon 3 here. Y1 is minus 6, minus y2, minus of minus is plus 13 we have here. We'll take the LCM of minus 4. 3 into 13 is minus 39 plus 32. That gives minus 7 upon 3 plus 10. Here again when we take LCM, 6 into 3 is 18, minus 32 plus 18, that gives minus 14 here upon 3 plus 16 upon 3. 13 minus 6 is 7. Then we will take 1 upon 3 out. We already have 1 upon 2 here. Minus 7 into minus 4 is 28. Minus 14 into 10 is minus 140. 16 into 7 is 112. Now 112 plus 28 is 140. So we'll have 140 minus 140, which is 0 here. That means the area of triangle is 0, which shows that all the 3 points are collinear. Now the second thing we know, centroid divides the line joining orthocenter and circumcenter in the ratio of 2:1. To look into that point, first consider only the orthocenter and circumcenter and find the point which divides this line in 2:1 ratio. We have the formula for internal division of a line in a particular ratio, say m is to n. The formula is given on the screen, just substitute the values, but in place of this, m is 2 and n is 1. We'll use this orthocenter and centroid and we'll find the particular point which divides this into 2:1 ratio. So the required point is m is 2 here, 2 into x2 is 10 plus n is 1 into x1 is minus 4. M plus n, that is 2 plus 1, comma m, that is 2 into y2 is minus 13 plus n, that is 1 into y1 is minus 6. Then m plus n we have. Now when we simplify this, 2 into 10 is 20, 1 into minus 4 is minus 4 upon 3, comma 2 into minus 13 is minus 26 plus 1 into 6 is minus 6 upon 2 plus 1 is 3. Here we'll have 20 minus 4 is 16 upon 3, minus 26 minus 6 is minus 32 upon 3. This is a point which divides the line joining the orthocenter and circumcenter in the ratio of 2:1 and 2:1, and this point matches the centroid coordinates, which means the centroid is dividing this line in ratio of 2:1. So in this video we have seen how to find the circumcenter, orthocenter and centroid when the lines of a triangle are given. We just have to find the point of intersection and then we'll find the values. Using this point of intersection itself, we can find the incenter as well. For that, you can refer to the previous video. So from the key points, the validation of first two things, we'll look into the third one in our next video.